And now it's Marek Miara from Fraunhofer Institute in Germany. So now we go directly to the sort of center of where it's all happening at the moment. The debate is high, isn't it, in your country?
Yes, yes. Thank you.
Yes.
Thank you for.
We should be very glad that he's here, actually, because he's been so busy with journalists. The last weeks, it has been hilarious for you.
Yes, and week before and week before.
And
But
week before.
thank you for invitation. And I will say, finally, I am able to speak in the heat pump wonder country. And to be honest, it's really not to overrate the role of Sweden by the communication and what have you done in the last years. It's always easy if I'm in other countries and they are talking to me, in our country it's sometimes very cold, like 0 degree.
Exactly.
And so the heat pumps are not working at all. And I just
Exactly.
showing up or to the north and it's working. So the role is really, really very, very important. I would like to start with a sentence from our Minister of Energy, Mr. Habeck. This quotation is more or less 1 year old, and I think he didn't know how important this sentence will be. Now this is like a political fight, and it's maybe even dangerous to make this citation so obvious again, but it's really important. And in this sentence we have like first part, how important the heat pumps will be. And they are already so important. And the second one is something which we see already. So in last year, we see that tremendous change. And he was talking about this ramped up in the short time, and this was really true. So we see, and you saw already many times today, that this is true. And it was not only the sentence, and I think this was really the crucial one. So there was also an action behind, and this very famous already and really very emotional discussed 65 rule in Germany, so that every new heating system should be powered by at least 65% of renewable energy, starting in January 2024. So it's very, very soon. And if you translated this sentence, this 65% to technology, it's like 98% of heat pumps and maybe 5 to 7 biomass heating devices. So it's really crucial for the heat pump. But as I said, now it's like it's causing a political typhoon in not only in Berlin but generally in media in Germany. Because I am getting these questions every day, really, I try to put it in a very short version also for you. And these are like a collection of myths and facts. And of course, all of you are already believers, so it's not so difficult to tell you the facts. But for example, this one, I can hear every day that heat pumps are only for new buildings. And it's definitely not true. So yes, it is possible to install the heat pumps also in existing buildings. I heard today that knowledge is power, and I think this symbol, this very easy and easy to understand sentences are really crucial for the communication. Next one, of course, is always better to refurbish first. No doubt about it. But no, it's in most cases, it's not necessary for a successful operation of the heat pump. So always better, but not always necessary. And this is also somehow like a fact and myth, which is really true. And this is my favorite one. Yes, it is also possible with radiators. So after each of interview, I get this question: it is possible without underfloor heating? Yes, it is possible without underfloor heating. So, and I will repeat it like five times more today. And these are myths and facts. And why these are facts? You can see on this slide, we are doing really field measurements since 20 years. So my knowledge is really based on facts, on numbers, and on results. We completed already 4 trials for heat pump monitoring field tests. Now we are just completing the next one, and perhaps we will start one more. I don't think so that it's even necessary. So we are not learning a lot because we are just one more time showing that it's working. But for the public, it's really crucial to see that it's still working. Since 20 years, we measured more than 350 heat pumps or houses with heat pumps. And it was starting with a new construction, so new buildings, and now we are investigating actually only in existing buildings, not retrofitted and retrofitted building, because the existing buildings, the variety is really very, very broad. If we would like to see some general results, so in this case, all these houses are in Germany, and we are assessing the air-to-water heat pumps and ground-to-water heat pumps as a 2 major types of heat pumps. It's not because we don't like other heat sources, but the other heat sources are not so statistically relevant so far. And if you are talking about the efficiency, it's always the relation between heat produced by or provided by the heat pump divided by the electricity which is needed. So for the air-to-water heat pumps in existing buildings from the last project, we have from the 100% of electricity, 310% of heat. So it's average annual value of 3.1. And for the brine-to-water heat pumps, we have even much higher efficiency, 4.1. So this is the situation in Germany. But of course, we are not the only country or only institute doing monitoring. So, for example, a very good trial in Switzerland, and really they are doing it even better, I will say, because they can also measure all of these heat pumps before making the field measurement. They are taking all of these heat pumps to the laboratory and looking how was the efficiency from the very beginning. And if we look on the results, so very similar slide, and this is not the mistake. So the values are really exactly the same. So it's really really good also for us, because from 2 different countries with 2 different ways to monitor, we have exactly the same results. In case of brine-to-water heat pumps, they reached even slightly higher efficiency, but for me it's really very, very comparable. So based on these values, we can definitely say that from the technical point of view, there are hardly any reason not to use heat pump in existing buildings. It's a very easy sentence, but I think it's a very important one for the end consumers. And now I have to ask you to focus, because it will be a graph. I will try to explain it. It's in a very, very easy way. We will see dependency between the yearly efficiency and maximal daily temperature of heat pumps, so maximal heating inlet temperature. And so it's on the y axis, it's decreasing efficiency, and on the x-axis, it's the temperature. And these dots with different colors are symbolizing different diverse heat pump systems. So all of them are air-to-water heat pumps. So each dot is one heat pump system in a particular house. And the colors of these dots are symbolizing the radiators, the mixed systems. So in some houses, they are just mixed systems. Part of the heating distribution is through the underfloor heating and part with the radiators. And the blue ones are purely underfloor heating systems. If you look on this graph, I will say that the first reflection of the first what you can see, it's that physics works. or thermodynamics even better. So because the higher the temperature, the lower the efficiency, generally speaking.
Yes.
But if we see just one part of this graph, so this is the efficiency between 3 and 4. So this is quite typical efficiency. And if we are reaching this efficiency, it's all good. And you see in this field all colors. So even in some cases, the heating systems with radiators achieved higher efficiency than heating systems with underfloor heating. So for me, this is like a proof that the heat pumps can also work very well with radiators. So I promised you. So this is the second time, 3 times to go. And of course, these all cases are quite. It's a huge number of houses. So I brought also 2 very specific houses to show you really in details. I think showing the examples are very good. If you pick only 1 or 2, it's always too less. But if you pick 1 or 2, but you have in your background 350, it's enough. And I picked these ones not because they are, I would say, architectonical perils, but they are really quite interesting. For example, the first one, it's not a good example of a good house. Or rephrased, if you have a heating demand more than 210 kilowatt hours per square meter and year, it's really like a G or even worse. But in this case, in this house, there was no retrofitting action at all, more or less. And the owners decided to install the heat pump, the air-to-water heat pump, and they changed only the radiators, 2 other radiators, low temperature radiators. And the result was 3.0 as a yearly efficiency in such type of house. I think it's a really good efficiency. It's possible. So it's not maybe the best way, but it's possible way. And sometimes, and if the owners will retrofit this building, which has to be done, no doubt, the heat pump will work just better. The second one, it's different example. In this case, there was some retrofitting actions, but they didn't want to change the radiators. So in this house, we have very old radiators with 73 already years old, and ground to water heat pump. So the high efficiency of the heat pump was one of the most important things for the owner. So he invests in ground to water heat pump and reached really very high efficiency of 4.5. So it's also possible in existing buildings. To conclude, we can see that heat pumps are increasingly being used successfully in existing buildings. So in Germany, there are more heat pumps installed now in existing buildings than in new one per year. The second one, underfloor heating is not the necessary requirement. So it's possible also to make it with radiators. And I think in the short term, and we are in this very specific point of time, I will say, or our history. The main challenge is not the main challenge is the speed of implementation and not the technology itself. Thank you.
Thank you. And I just love these examples with the actual houses. And I would like this one-stop shop to have such a picture of like 10 typical houses. And I can, as a consumer, just, point at the one that is most similar to my house and start from there. And then at the end, not only efficiency, but also euro that I, get back. Savings for me. So everything will be, This is a communication challenge, but not an impossible one. It's a fun one, I think. So